Well, welcome back, everybody. Thought I would show you the only pets I have. This is Krabby and Patty. And last year went on vacation to Florida, and the 4-year-old grandson, he decided that he wanted some crabs. Well, they parents bought him some crabs, and they decided that the best place to keep them was at Papa's house. So I think Patty is the active one today. They don't move much during the day, but at night is when they come out and do their business. So anyway, thought I would share that. They're not very active pets, but Papa's having to take care of them for now. So there's Krabby. He's decided to move on. It's about time for them to shed their shells. These are hermit crabs, and they will change shells as they grow, so I've got to get some more shells. Notice they're going away from the light. They're a nocturnal animal. Okay. The recap and the resistor are changed out. Some wiring. Instead of the highway of death, this is the bags. This is the components that came out of that. That's still quite a few components for such a small space, but what I plan on doing is starting at one end and going through the schematic and just point to point to point to point to point checks to see. One of the things that did is I soaked this in evaporust, and as you can see, it came out fairly well. It's a very simple condenser, no drive or anything like that. Just so we'll get that mounted back on soon. There goes my meter. But if you guys are not reading the comments that are being made on any video, not just mine, there's a lot of good information. I'm just going to pass that along. There's a lot of good information, good questions, good comments that are injected into the video process. And so if you're not reading the comments and the answers to them, then you're missing out. There's humor, there's entertainment, there's a lot of good information. So that's just me. It's part of the process. So we'll get the condenser mounted back on after I go through and check it. Get the condenser mounted back on. Go back and put the speaker on, and then we'll get the cord put on. Cord, and going to prioritize this and try to do it in the proper sequence. It really doesn't matter as far, we're not going to be able to use it until we get the stuff. But what you've got to think, am I going to damage anything by putting this cord in? At this point, no. If I put the condenser on, am I going to damage anything? Not at this point. If I put the speaker on, am I going to damage anything? No. All right. But if I put the speaker on first and then go to the condenser or the cord, I can damage the speaker. So the speaker is going to be the last thing we put on. So that's just some of the thought process, guys. Don't get the cart before the horse, as my daddy used to tell me. So the speaker is the most fragile, and if you'll watch all the other guys, and I try to do it also, is you start taking the fragile stuff away. Take it off. Get it away from me. I'm the one that's going to tear it up. So if it's not already damaged. So speakers are really fragile, especially this old, and it's real easy to just pop a finger through it. And everybody's done it at one point. Dropped a screwdriver, went through it. You know, it's so. I guess I've beat that horse enough. So, but that's what we're going to do. So I'll show you that as we get to that stuff. Let me go through and check all this stuff. Here's the top part of the chassis. Here's the wires going to the tuning condenser. Had to replace those. Replace these two wires going back to the loop antenna. And this is the dial light. I just cleaned it up a bit. The wires were in good shape. This is floating from ground. This bracket slides out, but some of these are grounded, and it uses the chassis ground for the second. And I've seen problems where people's replaced the wrong type and actually ground the transformer to the chassis. In this case, it wouldn't be the transformer winding, but there was a question in the comments about silver micas in this can. I didn't look, and to tell you the truth, I'm ignorant, and a lot of facts, a lot of stuff. And like I say, I learn stuff every day. So, and I said I wasn't going to mess with it unless it was a problem. Then a good subscriber of mine, Oleg, and I am not going to attempt to pronounce your name. Out of respect for you, I don't want to butcher it, but I'll post it up here for everybody to see. But Oleg had a great explanation about this can and where the silver micas are in other radios that came along in the late 40s and 50s. And I'd mentioned earlier in the video about looking at the comments, but Oleg had a great explanation. He has made a lot of great comments, and I've learned a whole lot from him. So, Oleg, I appreciate that, and keep up the good work. And you're very knowledgeable, and I appreciate your input, because it adds to this to my videos by you making those comments. And because the whole idea of this is to transfer knowledge to other people, and we all come away with this experience learning something, and that I just want to say a special thank you to Oleg for that. So I'm going to go back and redo this. I've already started with green, but I didn't like that. So what I'm doing is I'm going through the circuit, and as I trace it and verify that it is where it needs to be, then I'm coloring it orange. So once I get all that done, then we'll start putting everything back together. I've gone through all the radio circuit except for the power supply, and I'll do that separate. But I wanted to try to explain something to you guys, that one of the problems I've always had reading schematics is I get to looking for the components where they're located on the schematic, and that's not always the case. Not always the case. Now, in this AA5, we know that sometimes the chassis can be a potential, but in this one, you have what's called a common wiring, or it's kind of floating off of chassis ground. But there is a connection between the chassis and the floating, or the common one. And if you'll look at the schematic in this, that symbol represents the chassis, the metal part. This indicates the common wiring from the chassis. And if you'll remember, I said I'm having trouble finding this. And so I was looking around the oscillator coil. Okay. Also, this 0.25, I was looking around the oscillator coil. Okay. Simply because that's common sense. Well, forget common sense sometimes. Okay, this oscillator coil, I'll try to explain all this, is coming from the pin 5 of the 12 SA7 through a 60 picofarad capacitor, and it goes to terminal 1. That's terminal 1 of the coil. Well, there's the 60 picofarad going to number 1. Okay. Now let's go back. On terminal 1 is a 0.01 microfarad. And right there, it goes over to here. Well, this is on the coil, but this is the dummy. This is the dummy. So it's just acting as a terminal block. Okay. Along with that ties a green wire on the dummy. This is just the terminal block of this coil. So it goes from there, the green wire goes to C5, which is the tuning condenser, which is one of the connections on the bottom. The tuning condenser, C5, and the trimmer pad, which in turn goes to that symbol, which is a chassis ground, and so that's where it's soldered and bolted to the chassis itself. Now, from this part of the circuit, and this is my assumption, and I was wrong. That's a tap in the coil, and we won't worry about that at this point. Really, not necessary. We'll just know that it'll go back up to the pin 6, and for the demonstration, it's irrelevant. But on pin 3 of the oscillator coil, it goes to the common wiring, which is insulated from here, okay, which is down there, and it goes straight to the common wiring point, which is floating above the chassis ground itself. So these two components are nowhere near this coil. So if I take my ohm meter, and I've done this, and I go from number 3 of that coil to the chassis ground, I should get 220,000 ohms. Well, after I change the resistor, which is located right here on the 12 SA7 tube, no, I'm sorry, the 12 SQ7 tube, it goes between chassis and that common point, and there's where my 220,000 ohms is at. Now, the 0.25 microfarad also goes from the common point to the chassis ground, and it's located on the other end of the radio between this point and the chassis ground itself. So I hope that is clear as mud to you, but you know, sometimes you get to looking for components where they've drawn on the schematic, and that's not always the case. I'm sorry for the jittery video, but I'm holding the camera, and I've had a couple of cups of coffee this morning. But I thought I would explain that to you. I know it probably took a little bit longer than I really wanted it, but from what I've read on other people and watch other videos, is the schematic, reading schematics is problematic for a lot of different folks. So I thought I'd point that out. And another comment that I got was about the 35L6 and the 50L6. Well, this one has the 50L6. And then the notes. It's important to read all the notes, guys. After I got these comments, I went back and I read the notes, and I realized that I was talking about the 86 ohm resistor. Well, it's only used if the 35L6 is used, so it's not. So it's not there. So it's important to read all the notes, understand all the symbols, and go from there. Okay, getting the just soldered that back on, and get this soldered tip. I'm breaking in a new soldering iron. All right, then we'll roll this up like this. Something like this. Got me some new star washers. And I ordered some off the internet. Paid 10 cents a piece for these. And if you can put the hardware back on, all this stuff is there for a reason. Moving parts, vibrations, especially a small set like this, the vibrations have got to be tremendous. And so we'll put that on, tighten that down. Don't have to ape it, guys. I'm bad to ape things myself. So. All right, let's take a look around back. Now this is where we put the heavy duty soldering iron on it. Let me get that out. Had somebody comment about that getting hot there. This tip, I've dropped this gun no telling how many times, and don't have to heat it much, just enough to stick it. It's not really supporting anything, just keeps it in place. So but it takes a lot of heat, and there's a lot of dissipation on that large piece of metal. We're just trying to get it to where it'll stay in place. There we go. It's starting to flow a little bit now. Fortunately, there's no wires or anything involved in this. All right, there we go.